Hello everyone, welcome back to the channel. If you are new here, here is Geomicrosphere, where you are going to learn GIS and then Microsoft Excel, PowerPoint and Word. And then if you are new, please don't forget to subscribe. Let's get in. So today's video cut across how to perform drought analysis, how to calculate for drought severity and then drought frequency. So first of all, we are going to look at what is drought, how are we going to do it, and then the process that we are going to go through. So let's quickly get into it. So for drought monitoring, we have drought is a slow onset climate hazard that develop over time and affects water availability, vegetation health, and agricultural productivity. So in drought analysis, we have two key components that we are going to focus on. We have drought severity and drought frequency. So when we talk about drought severity, it describes how intense drought conditions are in a particular year, ranging from mild to extreme drought. And then we have the frequencies, they measure how often drought conditions occur over time. So we can take a period of, let's say, 2000 to 2025 and then determine how drought has been occurred between the time period from 2000 to 2025. And then also we have to calculate for drought, we use NDVI, that's the normally different vegetation index. And then however, because natural vegetation level differ from place to place, NDVI value are further standardized using the vegetation condition index, that's the VCI, to compare current vegetation condition with historical minimum and maximum. So we can compare the current condition of vegetation to the previous one, that's the minimum and maximum value for the previous years. And then also we have the standardized rainfall anomaly, so which show whether the precipitation of a given period is above or below the term average condition. We have the negative anomaly, and then we have the positive anomaly. And then also we have the drought frequency assessed by counting the number of years in which the defined drought threshold are exceeded. Okay, so let's quickly get into it. So to start with our drought analysis, we have our code here, which we are going to visualize each of them. So here you can see we have a final complete script, the drought frequency and severity. We have NDVI, vegetation condition index, and the rainfall. That's the variable that we use in this drought monitoring. And then we have our study area here, that is what you can see here. So let me check the study area for you to see. Alright, so this is my study area here, as you can see. So if you have your study area saved here, you can just import your study area here, or if you don't have it, you can create your own study area from here using a rectangle here to create your own study area. Alright, so this is the year that we use. So the start CI is the 2000, and the end year is 2024. And then we have our season start month, that is the June, and then season final end month, that is the October. And then we have our threshold. So the threshold is how we defined our variables. We have the extreme, the severe, and then the moderate. So less than 10 is severe, less than 10 is extreme, and then from 11 to 20 is severe, and then from 21 to 35 is moderate. That's how I defined the variables. And then we have our VCI, that is the aggregate scale, and then we have our map centered, and then here is our Landsat cloud masking. So here we use Landsat image, so we are going to do our cloud masking using the quality assurance data here, so you can see it here. Okay, and then we have our scale here. So here we convert the digital numbers, as you can see. This is the digital numbers, and then we use the constant variables to convert the digital numbers into the surface reflectance, as you can see here. And then also this is our Landsat 5 and then our Landsat 7. And then we have our Landsat. So here we use Landsat 5, Landsat 7, Landsat 8, and then Landsat 9. And then here is the year composite for our NDVI. So here you can see we have our variables here, which you can see here. So we have all our variables here, our NDVI, and then the months that we use. And then we have our vegetation condition index here, that's the NDVI minimum, NDVI maximum. Okay, and then we have our drought severity here. So here you can see we define classes as 4 is extreme, 3 is severe, 2 is moderate, and then 1 is mid or no condition. And then we have our drought frequency map here, and then we have our rainfall map, and then the others. So let's visualize our data here, and then you can see we have our legend here. You can see we have our drought severity, we have our rainfall anomaly, and then we have our drought frequency here. So first of all, let's visualize our rainfall anomaly. Okay, so this is our rainfall anomaly map. You can see how it varies. We have where we have rainfall, higher rainfall, and then where we have lower rainfall. So here you can see we have dry, that is the less than -1, and then we have normal. So you can see the normal condition cut across our steady area, and then we have our wet here, that is greater than 1 here. And then also let's visualize our drought severity. Okay, so this is our drought severity, which you can see we have the mid or no condition, that is greater than or less than 35. So all the blue area that we see here is the mid or no change. And then we have our moderate change here, which you can see it appear somewhere in our northeast. And then we have our severe here, and then we have our extreme. So you can see where the extreme drought severity is. Yeah, and then the next one is our drought frequency. So let's visualize our drought frequency. Okay, so this is our drought frequency. So you can see we have the low, moderate, high, and then the very high. So if you look at our steady area, there's no place that we have the very high. Then we have our moderate, and then the low. So you can see our drought frequency, the low dominate here. Then we have our others. So this is our percentage for our vegetation condition index. So you can see where we have normal vegetation. So you can see where water body is. The value is low because NDVI have low values at where water body, because NDVI calculates for vegetation, and the where water body there is no vegetation, so possibly there is going to be a low value at that place. And then we have our drought frequency, that is less than 35 that is from 2000 to 2024 here. So here you can see okay, all right, so this is our drought frequency map. And then here let's visualize our chart here. So the first chart that we have here is the seasonal NDVI mean, that is from 2000 to 2024. So let's visualize how the change has been occurred. Okay, so this is our seasonal NDVI mean. So you can see we have 2000 to 2024. So this is how our values has been changed. So if you put the cursor on it, you'll see how the value has been changed. So here how the trend lines look. So 2000 was NDVI value was 0.51, and then it increased to 0.6, and then it decreased to the 0.56 in that order. So you can see how the trend is going. So if you are doing any analysis with it, you can use this trend line to indicate how the NDVI value has been changing from 2000 to 2024. And then if you want to download it, you can download it as CSV, as SVJ, and then as PNG here. Okay, and then also we have the vegetation condition index in percentage here. So this one too, we can visualize it. This one too, you can see how the change has been occurred, as similar to the first one that we were looking. So you can see how if you put the cursor on it, you can see how the value is changing here. And then also we have our rainfall standardized anomaly. Okay, so this is our anomaly, and then you can see we have here we have 0.015, we have and then this is our trend line. So you can see where the trend line cut across, how the rainfall standardized anomaly has been changing from 2000 to 2024, or how it has been arranged, or how it's changing within as we progress from one year to the other. All right, and then Okay, so this is the simplest way to calculate for your drought monitoring analysis using your drought severity and then your drought frequency and also the rainfall anomaly. So here these are the data that we use. So here we use our NDVI, our Vegetation Condition Index, and then our rainfall here, which you can see it here. And then if you want to download each of the map, we have our export value here. Okay, so this is our export. So you can export our CSV here. You can export our geotiff, which we can export this map and then import it to ArcGIS Pro for further analysis. So if you want to download it, you can see we have the data here. We have the Savannah NDVI time series. These are the CSV, and then we have Savannah drought frequency. These are the geotiff. So you can click on run here, and then you can save it as CSV. So here we have our CSV here, and then the name is here. If you want to change the name, you can change it and then click on run, which is going to store in your Google Drive, and then you can go there and then download it to your PC. So this is the simplest way to calculate for drought monitoring using Google Earth Engine, and then our data sets as I have already showed you. That's our NDVI, our VCI, and then our rainfall. So thank you very much for your attention, and then I will leave the code on the comment section or in the description of this video. So if you want to try your hand on it, you can copy the code and then you try your hand on it. And also if you want to change the study area, you can change my study area to your own study area and then define your boundaries, and then you can run the same code and get different results for your study area. So thank you very much for your attention. Please don't forget to subscribe, share, and like. Thank you.